Question 1. Describe the role of the correlation coefficient. What does it measure? What are its bounds? Alright, the correlation coefficient is used to describe the shape of a collection of data. Okay, so let's draw a few pictures of some examples here. The correlation, first off, can either be positive, which is an upward slope, which means it has a positive slope. It could be negative, downward slope, or it could be neither, which would be something in the middle, something like that, or it could be up and down, something that's not distinct. Now obviously these lines aren't your data, because data isn't a line, but rather data are points. And so that's where the second part comes into. So positive, negative, or neither. And also it could be strong, strong, moderate, or weak. Strong, moderate, or weak. Okay, so now we're going to add in the dots to describe that. So in a strong correlation, the dots are close together. Okay, so that makes a strong correlation. Therefore, a weak correlation, if we're talking about a weak negative correlation, the dots are spread out a little bit more. So we can see there's still a pattern. It's still negative, but it's not super strong. It's not as, or we can't be as confident about our point based on where we're at. Okay, and then, so if we call this moderate and then weak, a weak correlation would just be a correlation that's super just, I mean, barely there at all. You may call it negative because there's not too much in the corners there, but that would be a weak correlation. Now the correlation coefficient is a number between -1 and +1. It's a decimal that we normally represent in two decimal places. And a positive, if the correlation is positive, if the data is moving from bottom left to top right, then it's going to be a positive number. If it's moving down, it'll be negative. And then the closer to 1 that it gets, so I'll draw a little number line here. So this is 1, this is -1, and this is 0. Okay, so we have positive on this side, negative correlation on this side. And if we have if it's close to 0, then it's weak. And then if it's closer to the outside, then we have a strong correlation. So real quick in review, if it's going up, then it's positive correlation, down, negative. Or if it's neither, if it's either got an up and down pattern or it's just horizontal, then we call it neither. And if the dots are close together, we call it strong. If they're spread out but still pretty tight, we call it moderate. Super spread out, we call it weak. If it's close to 0, that's weak. Close to negative or +1, that's a strong correlation. So that is your correlation coefficient. Question 2. Sketch a graph of 10 xy coordinates on an xy plane where the data have a strong linear positive correlation. Okay, this I'm going to show you by hand. So we're looking for a strong relationship, which, remember, that means that the data points are close together. Okay? And then a strong positive correlation means that we're going from bottom left to top right. So we're going up. So if we were to graph 10 points, we could say this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 7, 8. Maybe we have one at 1, 1, 2, 2, 3, 3, 4, 4. Maybe we also have one at 4, 3, and 5, 4, and then 6, 6, 7, 7, 8, 8. Okay? So we have our points here. And then if we were to draw a trend line, or a line that represents the data, we would have our strong, because they're close together, and positive, because it's going from bottom left to top right. You can do that on Word by clicking on the Insert, and then Chart, and then XY scatter plot, if you'd like to do it in Word. Question 1. We're going to be doing this whole thing on Excel. The correlation coefficient between head length and body length of the gharial crocodile is, okay, in order to find the correlation coefficient, we're going to need to open up the Excel spreadsheet quantitative inference procedures, as well as the file that contains the data that we're looking for. Okay, and we'll start with the head length. We're going to copy the head length and paste it into our quantitative inference sheet. And remember to come down here to the linear regression link on the bottom, or the linear regression page, excuse me. Now in our explanatory variable, that's where we're going to paste our head length, because we want to use the head length to predict the body length. So we'll come back over to here and grab the body length and paste it into our response variable. Okay. Now this chart right here is going to contain all of the answers that we'll need for this section. So the correlation coefficient, remember, is the R, which is found right here, which is 0.986. Question 2. The covariance of the head length and body length of the gharial crocodiles is, okay, so in order to find the covariance, if you remember, the covariance can be found by hand by multiplying R by the standard deviation of our explanatory variable multiplied by our standard deviation of our response variable. But conveniently here in Excel, it gives us to us right in this final column. So we're looking at about 1533 as the covariance. Question 3. Create a scatter plot representing the relationship between head length and body length of the gharial crocodiles. Paste your scatter plot below. Okay, the scatter plot, another convenient thing about this Excel sheet, is given to you right here. Okay, you can copy and paste that into your Word document. It might help to add a text box down at the bottom to label what your X and Y variables are. Remember, your X variable is your explanatory, which is the head length, and then your Y is what you're trying to predict, which is the body length. Question 4. Discuss the relationship you see in the scatter plot between the two sets of bivariate data for the gharial crocodile. So it's pretty obvious that this is a strong, and remember it's a strong correlation because the dots are close together, are clustered close together, and it's positive because it's going from the bottom left to the top right. So we can say that there is a strong positive linear relationship between head length and body length. Now what that means in simple English is that if we know the head length of a gharial crocodile, we can be strongly confident in predicting the length of the body. Okay, so we are positive, we have a high confidence rate in predicting the body length given the head. Okay, Lesson 21, Part 2 in SPSS. Question 1, the correlation coefficient between head length and body length. Okay, in order to find the correlation coefficient, we're going to come up here to Analyze, and then we're going to come about a third of the way down to Correlate, and we're doing bivariate. Okay, these will most likely start on your left-hand column there. You want to hop them both over, because we're going to be using both. We also, under the options, want to check the means and standard deviations, because we're going to be using that here in just a second. Okay, so here they are. We have the correlation coefficient is in SPSS is named the Pearson correlation, which can be found right here or right there. Okay, it should be the same number, the 0.986. Question 2. the covariance of the head length and the body length of the gharial crocodiles is, okay, so the covariance, we're going to use these numbers right here to find that. Okay, if you remember the covariance, the equation for the covariance is your correlation coefficient, or this 0.986, times the standard deviation of x, which is your head, 14.397, times y, which is 108. So multiply those three numbers together, and you get 1,534. And that is the covariance. Question 3. Create a scatter plot representing the relationship between head length and body length of the gharial crocodiles. Okay, so we're going to come back to our other sheet here, and this is where we're going to find the QQ plot. We're going to graph legacy dialogues, and this is going to be a scatter plot. It's just going to be a simple scatter plot. That's all we're looking for. Okay, now under our x-axis, the second line right here, we want to put in the head, remember, because that's what we have, and then our y is what we want to predict, which is the body. Okay, all that good, and voila, there is your QQ plot, which looks very linear, so we are just fine in that assumption. So, question 4, discuss the relationship you see in the scatter plot between the two sets of bivariate data for the gharial crocodile. Okay, so there's a positive linear relationship between the head length. Okay, so with this 0.986, that's a very strong, and since it's a positive number, not negative, we know it's positive. So the relationship between the head and the body is positive, which means as the head gets bigger, so does the body get